Okay, good day. So let's take up in algebra polynomials. We have polynomial. Now in binomial, we have actually three. We have number one, we have the monomial. We have binomial. And trinomial. Or actually, we call this as the multinomial. Now, before we start with polynomial, let's go back first to record algebraic term. Okay. Now, say we have example 3x squared. Now, in that term, 3 is the coefficient. We have x is the variable. And 2 is the exponent or power. Exponent or power. Now, in this example, so for example, we take again 5x squared or 5x cubed. Then this is also another term. If we add 3x squared, another term. Then if we add 3x, okay? So this is now actually a polynomial and this is actually trinomial. Now, when one term is only involved, this is a monomial. Okay? When 2 is involved, so there are two terms and that is binomial. And when we have three terms, that is trinomial. Trinomial. Now, in this term 3x, it is understood that there is a power of 1 here, but we do not write it there 1. Also, when we have x squared like that, so there is actually x coefficient 1 here, but again, we do not write 1 in that term. Okay. Now, the division of the terms are determined by having this operation, addition and subtraction, or the plus and minus sign. Now if we add here 4, then this 4 is actually a number, or that is the constant. Okay, so I hope that this discussion will help us. So let's proceed to the operation involved in polynomial. Okay, but we will start first with monomial. Now in monomial, so we'll be dealing with addition, subtraction, multiplication, and division. These are actually the for operations in mathematics. Okay. Now, there are procedure to be followed in operation of monomial. Now, let's start with addition of monomial. Okay. So, for number one, addition of monomial. So, this simply means that we are going to add the terms of the monomial. Okay. So, actually, we have here, for our example, find the algebraic sum. Okay, we are right. Find the algebraic sum. Okay. For I have only selected some of the numbers in our module. So we have here number 3. We have 21 y squared, negative 17 y squared, negative 3y squared, and negative 4y squared. Okay. Now, we have 4 monomials and they have different signs. Now, what we are going to do here is to add for our solution. We have 21y squared, then add negative 17y squared, then add negative 3y squared, then add negative 4y squared. Okay, this actually, since all operations are addition, you can actually write that like this way: 21y squared minus 17y squared minus 3y squared, then minus 4y squared. Okay, now actually, we can get the summation, algebraic summation of the coefficient, then factor out y squared, and this will yield negative 3y squared. And this is now our answer. Okay, so let's now proceed to our number 2. So for problem number 2, question number 2, actually we are going to consider question number 5. So for question number 5, we have 9x squared, negative 7x squared, 4x squared, negative 3x squared, okay, then 3x squared, then we have negative 4x squared. Okay, so actually you will see that there are same term here and with opposite sign. Okay, so actually I can show you true solutions here. So for our number 1, we have 9x squared minus 7x squared. So I did not include the positive, the addition. Pwede naman, it can be done. And we have plus 4x squared Okay, but to make it correct for our procedure, let us add, so plus negative 7x squared, then plus 4x squared, then plus negative 3x squared. Okay, we have, this should be negative 3x squared, then plus 3x squared, then plus negative 4x squared. Okay, now to solve this combination or addition, the best is to cancel out first those terms with same term with opposite sign. So we have here negative 3x and we have positive 3x. So we can cancel this out. Then we have negative 4x and we have 4x squared here. So we can also cancel that out. And therefore we have 9x squared plus 7. Okay, this is negative. So plus negative 7x squared. And therefore, that is just simply 9 minus 7. And we have our answer is 2x squared. Okay, that is our answer. Okay, next. Okay, so that is our answer. Then next, we have problem number 6. I will erase this first. Okay, so let's proceed to number 6. Okay. For number 6, in number 6, we have 1/3 of A, 1/2 of A, negative 7/2 of A, 5/6 of A, and negative 3/4 of A, then A. So we have 1, 2, 3, 4, 5, and 6 terms. Okay. So to write that, we have 1/3 of A plus 1/2 of A, then plus negative 7/12 of A, plus 5/6 of A, plus negative 3/4 of A, then plus A. Okay, so how are we going to combine this? So we have to think of a number that is common, and we call that as the least common multiple. Now we are going to use that as our LCD. When we speak of LCM, this is the least common multiple. Okay. Now, what is the least common multiple? That is a number that is the smallest number that all these numbers 3, 2, 12, 6, 4, and we have here 1 are the factors. So in these numbers, we have 3, 2. So we have 3, 2, 12, 6. We did not include 1. The least common multiple for these numbers, is 12. Okay. And we are going to convert all these terms to a divisor of 12. So 1/3 is simply the same as so what we're going to do is to have this denominator 12, then 12 divided by 3 is 4, and then multiply it by 1. That is our operation in improper fraction. And so 12 divided by 3 is 4. Okay, this simply means that 1/3 is the same as 4 over 12. Then 1/2 is the same as 12. Okay, we have 12 divided by 2 is equal to 6. Then we have 5 over 6. Okay, 5 over 6 is we have 12. Okay, 12 divided by 6 is 2. Okay, so what you are going to do here is to first is to divide. Then multiply it in the numerator. Okay, so this simply means that we have to do this operation. 12 divided by 6. Then multiply the quotient by the numerator, which is 5. And therefore, this is 12 divided by 6 is equal to 2 multiplied by 5. And this is equal to 10. Meaning to say that our numerator should be 10. Okay? That is for 5, 6. And for 3/4, so 12, we have the LCD is 12. 12 divided by 4 is 3 times 3 is 9. Okay. So these are the equivalent of those fractions. So 1/3 is 4 over 12. So we have 4 over 12 of A. Plus, what half is equal to 6 over 12 of A. Okay? Then, since this is positive, we can multiply positive with negative to become negative. So we have minus 7 over 12. Okay, I forgot to convert 7 over 12. So 7 over 12. Okay. This is also 7 over 12. Yeah, okay. So we have minus 7 over 12. Then plus 10 over 12. Then minus 3/4. 3/4 is 9 over 12. Okay. I have to add here A. Okay. So 3/4, we are now on 3/4, then plus 1. That is 12 over 12 of A. Okay. So we have 4 over 12, 4 3/4, 4 1 2/2. We have 6 over 12, negative 7 over 12, copy. Then we have 10 over 12, 9 over 12 for 3/4, and we have 12 over 12. Now you will see that our coefficients are all fraction with the same numerator. And what we're going to do is just to add algebraically. We have 4 plus 6 minus 7 plus 10 minus 9 plus 12. And our answer to that is equal to, so we can add actually the all positive. So we have 4 plus 6 plus 10, that is equal to plus 12. So we have 4, okay, 4 plus 6 plus 10 is equal to 20 plus 12 is equal to 32. 32. Then minus, we have 7, 9, and 9 plus 7 is equal to 16 over all over 12. And we have to multiply it by A. And our answer is equal to 16 over 12 of A. However, 16 over 12 is not yet in the lowest term. And so we can divide 16 over 12 all terms by 4. So divide the numerator and denominator by 4. This will give us 4 over 3. And therefore, our answer is 4/3 of A for that operation. Okay, that is something that is quite neat foundation in operation involving fraction. Okay, so I hope that we have that solution. So let us now proceed to, okay, this one we have number 9. Okay, for number 9, we have 24x squared. Then we have negative 3xy. Then we have 12x squared, negative 4xy, and we have 18y squared. Okay. Now you will see here that this is again another subtopic. So we are going to combine terms with variable in second order, or the power of 2, and we also have another variable y. So therefore we have our variable is x and y. Okay. Now, actually, before we combine this, let us have a discussion first of how to arrange properly these terms. Okay. Now, when we involve two variable, we have to follow this uh, method that our variable must be arranged algebraically or alphabetically. And for the first variable, this term, our first constant or first variable is x. So this is our first variable. And y will be our second variable. Okay. Now for the, we have to arrange the first variable in descending order. While for the second variable in ascending order. Okay. Therefore, if we are if we are going to arrange our term, we have x squared. Okay, then we have we have next will be xy, and last will be y squared. So you will see that x has a descending power of x, and we have ascending power of 1. Okay, so here we have to add 24x squared. Then we have plus 12x squared. Okay, then x. So we have already taken two terms for x squared. Then minus 3xy. Then minus 4xy. And we have last is 18y squared. Okay. Now we can factor out this x squared. So we have 24 plus 12. That place a parenthesis, x squared. Okay. Then we have plus, okay, so we have negative 3 minus negative 4. Then we have xy. Okay, actually we can replace this with a parenthesis. Then plus 18y squared. Okay, so 24 plus 12 is 36. So we have 36x squared. Then we are going to add a number with the same sign. This is negative, so that will be negative 7xy, then plus 18y squared. And therefore, that is our final answer for number 9. Then let's proceed to number 13. Okay, for number 13, we have 3y raised to m, 2y raised to m, negative y raised to m, negative 3y raised to m. Okay, so we have 4 terms to be combined. Now here, this is different because our exponent, okay, our exponent is a variable. Okay, exponent is variable or unknown. Okay, or simply we call this unknown. Okay, so we have to do the same for the exponent. We have just to add the exponent. Okay, so we are no, we are just going to copy that one. So we are going to add the exponent. So we have 3y raised to m plus 2y raised to m, then plus negative y raised to m, then plus negative 3y raised to m. Okay, so we have addition of monomials. So we have 3 plus 2, then minus 1, minus 3, then y raised to m. And therefore, we have 3. We can cancel out 3 here. We have 2 minus 1, and therefore, our answer is 1. Y raised to m or y raised to m. Okay, so this is our answer. Let's proceed to number 14. Okay, for number 14, so number 14, we have negative 2 x raised to n, y raised to m. Then we have 4 x raised to n, y raised to m. Then negative 3 x raised to n, then y raised to m. Okay? So this is very simple because all our terms involve the same variable and exponent. So we are just going to add algebraically the exponent, the coefficient. So we have negative 2 x raised to n, y raised to m, plus 4 x raised to n, y raised to m, then add negative 3 x raised to n, y raised to m. Okay? So that's simply negative 2 plus 4 minus 3, then parentheses x raised to n, y raised to m. And that will be equal to, will be equal to 1. Okay. So, actually, negative 1. So, that is negative 1 or negative x raised to n, y raised to m. And this is our final answer. Okay. For number 16, so we have number 16. So, we have 5 x raised to n, 2 y raised to m, negative 3 x raised to n, and 4 y raised to m. Okay? So again, we have two variables with different exponent. So we have to arrange that alphabetically. So we have to start with x. So we have 5 x raised to n, then plus negative 3 x raised to n, then plus 2 y raised to m, then plus 4 y raised to m. Okay, so we have 5 minus 3. This is equal to 2. 2 plus negative 3 is equal to 2. Then copy x raised to n. Then 2 plus 4 is 6. So that is positive. So plus 6y raised to m. Okay, so you will see that our answer is in alphabetical order. And that is the correct procedure. Okay, so we have this as our answer. Okay, so let's proceed to number 18. So for number 18, so we have negative 2 a raised to n. We have negative 3 a raised to n and negative 4 a raised to n. You will see in this problem or question that all our coefficients are negative. So we have negative 2 a raised to n, then plus negative 3 a raised to n, then plus negative 4 a raised to n. Okay, so we have negative 3 minus 4 a raised to n. And therefore, we have negative 9. For number 18, negative 3, negative 2. Sorry, this is negative 2, negative 2, negative 3. Okay, this is negative 9 a raised to n. And this is our answer. Okay. For our last number, we have number 20. Okay, for our last number for addition of monomial, we have 25 x raised to 6. And we have negative 8x cubed. We have 3x raised to n, negative 18x raised to 6, negative 3x cubed, and we have 2x raised to n. Okay, so since we have a variable exponent, this simply means that it will have any number. Any number can be assigned to this n. Therefore, this is unknown. Therefore, that should be the first one in the order. So we have 3x raised to n, okay, plus 2x raised to n, okay. Then next will be 6. So we have plus 25x raised to 6, then minus 18x raised to 6. So actually, to make it correct and form, we have to add negative 18x raised to 6. Okay, so we have next will be plus negative 18x cubed, then plus negative 3x cubed. Okay, so we are on addition of monomial, so there should be the sign. The sign should be shown. But actually, you can go directly to negative, so that will be involve addition and subtraction. So we have 3 plus 2 is 5 x raised to n. Okay, so that is for these two numbers. Then when 25 minus 18 is equal to 7, so plus 7 x raised to 6. Then for the last, we have negative. Okay, so we have 5x raised to n plus 7x raised to 6. Then we have, for x cubed, negative 8. Then we have negative 3, that is negative 11x cubed. Okay, this will be our answer. Okay, so that ends our video for addition of monomial. Okay, so let's proceed to subtraction of monomials. Now we have to follow the operation or the procedure for the subtraction of signed numbers. That is to change the sign of the subtrahend. Okay, so in subtraction of monomial, we have to change the sign of the subtrahend and proceed to addition. Okay, so for number 1, we have 16b minus 11b. Okay, so we have 16b. Change this minus sign to sign of addition positive, then plus 11b. Okay, we have changed the sign of the subtrahend. And therefore, our answer is 16 plus 11 is 27b. For number 2, we have negative 7m squared minus 3m squared. Okay? So since we have a minus and the sign of 3 is positive, we can write it this way. We have 7m squared minus, then that is positive 3m squared. So we have just rewritten this into this form. So we have negative 7m squared, then change the operation from subtraction to addition, then change the sign of the subtrahend from positive to negative 3m squared. And therefore, our difference is, okay, now this time we are adding, we have changed the operation from subtraction to addition, and we are adding same number, same sign number, but of negative and negative. So what is the rule? The rule is get the algebraic sum of the absolute value, that is 7 plus 3 is equal to 10, and get the sign involved, that is negative. And we have negative 10m squared. Okay. So for number 5, we have 3xy then minus negative 9xy. So this is just the same as number 1. So we can do directly. We have 3xy, change the operation to addition, then change the sign of the subtrahend from negative to positive. So 9xy. And therefore, we are adding 3 and 9. And therefore, our answer is it's 12. Okay, 12xy. Okay, that is 3, 9. So that is 12xy. And for number 6, we have number 6. So we have 12 x raised to n minus 5 x raised to n. Okay. So we have 12 x raised to n. Then change the sign of the operation plus, then negative 5xn. And therefore, we have to get the difference of 12 and 5. That will be equal to 7. And copy x raised to n. So that is for number 6. For number 7, we have negative 7x raised to m minus 3x raised to m. Okay. So we have negative 7 x raised to m, then plus negative 3x raised to m. Okay. So we are adding same negative sign. So just get the absolute sum. So that is 7 plus 3 is 10. Then we have to get the sign negative. Negative 10x raised to m. And for number 10, we have negative 6 x raised to n y raised to m minus negative 4 x raised to n then y raised to m. Okay, so we have negative 6 x raised to n y raised to m, then plus, okay, so we have to change this sign to positive sign for x and y m, and therefore we have to get the difference of 6 and 4, and that is equal to 2, and get this negative sign for 6, for 6 is larger than 4. So we have negative 2x raised to n y raised to m. Okay, so that ends our discussion for subtraction of monomial. Okay, so let's proceed to multiplication of monomial. Now in the law of exponent, we have in multiplication of monomial, we have to add the power or the exponent of the same term. Okay, so let's start with number 1. We have 3a to be multiplied to 2a. So just multiply the coefficient, 3 multiplied by 2. Then we have a. This is understood that is 1 here, and we have exponent 1 here. So we just add the exponent, 1 plus 1. And therefore, we have 3 times 2 is equal to 6a squared. And that is our answer. So let's proceed to number 3. We have 9a squared and negative 6a squared. Okay? So first, we have to multiply the coefficient. So we have 9 multiplied by negative 6, then a, then add the exponent 2 plus 2. And therefore, we have 9 times 6. So this is positive times negative is negative. So that is negative 54a, then 2 plus 2 is equal to 4. And so we have negative 54a raised to 4. And number 5, so we are solving the odd numbers. We have negative 2x squared y squared, then multiplied by x squared y cubed. Okay, so we have to multiply the coefficient first. We have negative 2 multiplied by 1. Okay, it is understood that there is one here. There is one there. Okay, so we have x, then 2 plus 2, then y, 2 plus 3. Those are the exponent, 2 plus 2 and 2 plus 3. And therefore, our answer is negative 2, x raised to 4, y raised to 5. Okay, and for number 7, we have a squared, b cubed, c raised to the 4th power, multiplied by a squared, b, c. Okay, so since we do not have coefficient, it is understood that the product is 1. So we have a raised to 2 plus 2, then b cubed, we have b 3 plus 1, there is 1 here, and plus c raised to 4, plus we also have 1 for c, and therefore our final answer is equal to a raised to 4, b raised to 4, and c raised to 5. So we have a to the 4th, b to the 4th, and c 5th. Okay. Okay, so if we have now find the product for our module, we have find the product. And when you speak of find the product, that is the same as multiplication. So for number 12, we have negative a multiplied by negative b multiplied by negative c and negative d. And therefore, we have to multiply negative 1 by negative 1 multiplied by negative 1 and negative 1, because we have for actually this is negative times negative 1 times negative 1 times negative 1 times negative 1. Then a, b, c, d. Therefore, our answer is we have negative is negative positive times negative is negative times negative is positive. So we have positive a, b, c, d. Okay, for number 14, we have negative a cube b, then negative ab to the 4th, then a, b. Okay, so we have negative 1 multiplied by negative 1 multiplied by 1 here. Okay, so we have a, then 3 plus 1 plus 1. So we have 1 here and we also have 1 here. Then we have b raised to 1 plus 4, then plus 1. Okay, so we have negative times negative is positive times positive is positive. So they are positive a raised to 5, b raised to 6. For number 14, so we have a raised to 5 and b raised to 6. Okay, so let's go back to number 13. So I forgot number 13. We have 4a cubed negative 10 a squared b, then 25 ab squared, then negative a b to the 4th. Okay, so 4a cubed minus 10 a squared b multiplied by 25 ab squared and negative ab squared. So we have 4 multiplied by negative 10 multiplied by 25 and multiplied by negative 1. And we have a raised to 3 plus 2 plus 1 plus 1 here. Okay? So we have 1 here, another 1. Therefore, we have A raised to 3 plus 2 plus 1 plus 1. Then B. Okay, I will write it here below. We have B. Okay, B raised 1 plus 2 plus 4. Okay. So we have positive times negative is negative, multiplied by positive is negative, multiplied by negative is positive. And 4 times 10 is 40, multiplied by 25 is 1,000. That is 1,000. A raised to 3 plus to 5 raised to 7. Then B raised to 1 plus 2 is 3 plus 4 is 7. So we have 1,000 A raised to 7, B raised to 7. Okay, so let's continue. Let me erase first our writings on the whiteboard. Okay, so again, let us have number 15. For number 15, we have A raised to N, then A raised to N. Now this time, we have to multiply monomial with unknown exponent or variable exponent. So we have to apply the same. We have to add exponent. We have A raised to N plus N. Okay. So we have A, N plus N is equal to 2N. And therefore we have A raised to 2N. Number 17, we have negative 14 A raised to M, then negative 6 A raised to N. Now we have here different exponent. So we have just, but we have the same base now. We have the same base. So negative 14, that is equal to negative 1. Okay, wait. Negative 14. So negative 14 multiplied by negative 6. Then we have A, M plus N. So negative times negative is positive. And 14 times 6 is equal to 84. Then A, we have to write M plus N. We cannot combine M and N because they are different. So our answer is 84A M plus N. Okay, for number 19, we have A squared, then A raised to N. So we have monomial with numeral coefficient, exponent and unknown exponent. But they have the same base. So let us just multiply A. So we have A, 1 times 1 is 1, A, then raised to 2 plus N. So this is now our answer. Okay. For number 21, we have negative 3 A cubed B raised to N. Then we have AB raised to 4. Okay. So we have number 21, we have negative 3 A cubed BN, then we have A B to the 4th. So we have to multiply the coefficient first, negative 3 multiplied by 1. Then we have A 3 plus 1. So there is 1 here. Then B raised to N and plus 4. Okay. So we have negative 3 times 1 is negative 3. A raised to 4. So we can combine this. However, for B, we have N plus 4 as our exponent. We cannot combine N and 4. So we have just to add it. N plus 4. For that is for number 21. And for number 22, we have 3a raised to n, negative 2a, then 3a raised to 4, then 6 raised to a. Okay, so we have 3a raised to n, negative 2a, 3a to the fourth, and 6a. So we have to multiply first the coefficient. We have 3 multiplied by negative 2 multiplied by 3 multiplied by 6. Then we have a raised to, we have n, then plus 1 here, plus 4, and plus 6. And therefore, our answer is 3 times negative 2 is negative 6 times 3 is negative 21 times 6. And so that is equal to negative 108 a raised to n plus 1 plus 4, 11. So 1 plus 4, there should be 1 here. And this should be 6n plus 6. Okay. So that ends our topic in multiplication of monomial. Okay, so let's proceed to division of monomial. Okay. Now for the division of monomial, actually this is also included in law of exponent. We can actually cancel out or apply the law of exponent by adding the exponent in the numerator and subtracting the exponent in the denominator for term with the same base. Okay, so let us have this example. Let's simplify the following. Okay, so we have number 1. We have negative 56 a raised to 4 x raised to 4 divided by 8 a cubed x. Actually, that is just the same as negative 56 a raised to 4 x raised to 4. Then let's put this to parentheses. Okay, divided by negative 8 a cube x. This is our representation in the horizontally. Okay, so but it is quite easier to perform it in fractional form. So we have to divide first the coefficient. So we have negative 56 divided by negative 8. Then let's start with the numerator. We have a raised to 4. Then just subtract the exponent in the denominator. So that will be 4 minus 3. Then we have x, 4 minus 1. Okay, whichever is larger, that exponent will govern. So if the exponent, say for example, we have a cube and we have a raised to 4. So therefore, we have to use the denominator. So we have a raised to 4 minus 3 in the denominator. Okay, and we have to write 1 here. And therefore, this will be equal to 1 over a. Now for here, we have 4 minus 3, that is equal to a. Okay, so we have negative divided by negative will be positive, and 56 divided by 8 is equal to 7. Then we have a 4 minus 3 is equal to 1. Then x raised to 4 minus 1 is equal to 3. But we don't need to write 1 there. So our answer is 7ax cubed. That is our final answer. For number 3, we have 49xy divided by negative 56 x squared y squared. Now this time, 56 is larger than 4. So we have 4 divided by negative 56. Then we have, since x squared is larger than x, therefore we have x squared minus 1 in the denominator. And we also have y squared minus 1. We have 1. It is understood that there is 1 exponent there. So therefore, we have to write also 1 here. Okay? So we have 4 times 1 is 4 divided by 56. So that will be negative. Okay, actually, 56 divided by 4 divided by 56 divided by 4. So we have negative. This is positive divided by negative is negative. Then we have 1 over 56 divided by 4. 56 divided by, this is actually 49. Sorry. 49. Okay. So I will, now what are we going here? So we have 49 and 56. So we have to divide that by 7 because that is the common divisor. So we have to divide 49 by 7 and negative 56 to be divided by 7. Okay, this is negative sign. And we have 1 over x raised to 1, then y raised to 1. Okay, so we have 49 divided by 7 is 7. And we have 56 divided by 7 is negative 56 is negative 8. Then we have 1 over x, y. So our final answer will be negative. So our final answer should have been negative 7 over 8xy. So there should be negative sign. Okay. So let's proceed to number. Okay, so negative 7 over 8xy. Then for number 5, negative y raised to 7, z raised to 12, then negative y raised to 5, c raised to 3. Okay. So actually, we can do also cancellation. Okay. So this is another way of solving division of monomial. So I will write number 5 here. We have negative y raised to 7, z raised to 12, divided by negative y raised to 5, then c cubed. Okay. So I will solve it in two methods. We have negative divided by negative is positive. So we can neglect that one. So we have y. Okay. So y 7 raised to 7 minus 12 and z raised to 12 minus 3. And therefore our answer will be y Okay, 7 minus 5. Okay, this should be 7 minus 5 and 12 minus 3. And therefore, our answer will be y squared, then z raised to 9. Okay, however, we can do this also this one. We have y raised to 7, z raised to 12, divided by negative y raised to 5, z raised to 13. So we have just cancel out the negative sign. And we have y. We have 5 here. Therefore, what will be left here is 2. And here, cancel this one. Then, from 12, what will be left is 9. Okay? So, just copy y squared z raised to 9. This is more easier actually. But you have to follow this procedure in our module. Okay, for number 8, we have 28 c squared d raised to 4 all divided by negative 7 c raised to n then d. Okay, so we have 28 over negative 7. Then we have it can be c 2 minus n, then d 4 minus 1. Okay, so there is 1 here. And therefore, we have 28 divided by negative 7 is negative 4. And we have c raised to 2 minus n, then d cubed. Okay, we can have this answer, okay, for number 8. Or we can also do this way, that we have 28 over 7, then we have c raised to n minus 2, then d raised to 4 minus 1. So we have negative 4 d cubed over c raised to n minus 2. They are actually the same, and they are correct. Okay, for number 10, let's proceed to number 10. For number 10, we have 12 x raised to n, y raised to n, divided by 6x squared y. Okay, so we have 12 divided by 6. Then we have x n minus 2, then y n minus 1. Okay, we have 1 here. So 12 divided by 6 is 2, x n minus 2, y n minus 1. Okay, for number 12, we have negative 45 a raised to 2n divided by negative 9 a raised to n. Okay, so we have negative 45 over negative 9. Then we have a raised to 2n minus n, that is n in the denominator. And we have negative divided by negative is positive. 45 divided by 9 is 5. Okay. So that is 5. A raised to 2n minus n is equal to n. So our answer is 5a raised to n. Okay. Now we have an exponent which is called a zero exponent. So let's discuss zero exponent. So the rule is any number or any expression raised to 0 is equal to 1. So that is the rule for zero exponent. when do we have zero exponent? That is when we have operation involving addition and subtraction wherein the answer is 0. Okay, so let's start with simplify the following. For number 1, we have 27 x raised to n over 27 x raised to n. Okay, now you will see that we have 27 divided by 27. Then we have x n minus n because we have to subtract the exponent of the denominator to the numerator. And therefore, we have 27 over 27 is 1. And we have x n minus n is equal to 0. Okay. So, any number raised to 0 is equal to 1. Therefore, 1 times 1. This is equal to 1. So, 1 times 1 is equal to 1. Okay. For number 3, we have x squared y cubed divided by 3x squared y cubed. Okay, so we have this understood that there is 1. So we have 1/3 x raised to 2 minus 2, then y 3 minus 3. Okay, so this is equal to 1/3 multiplied by x raised to 0, then y raised to 0. However, x raised to 0 is just equal to 1. So we have 1/3 multiplied by 1 multiplied by 1. And therefore, our answer is 1/3. Okay. So very simple. For number 5, we have 27 x raised to 2n over 9 x raised to 2n. So let's divide first the exponent. The coefficient. We have 27 divided by 9. And we have x raised to 2n minus 2n. And we have 27 divided by 9 is 3. And x raised to 2n minus 2n is raised to 0. But x raised to 0 is equal to 1. So we have 3 times 1. And therefore, our answer is 3. For number 7, we have 25 a cubed b squared divided by 5 a raised to n b squared. Now, we do not have, we have zero exponent here only in b. So, we have 25 over 5. Then we have a raised to 3 minus n. Then b raised to 2 minus 2. So, this will be, okay. So, this will be equal to, we have, okay. So, we have equals, let us write it here. 25 divided by 5, 25 divided by 5 is 5. Then just copy a raised to 3 minus n and b raised to 0. So this will be equal to 5 a raised to 3 minus n then multiplied by 1. Okay, so our answer is 5 a raised to 3 minus n. Okay, so that is for number 7. However, we can also proceed with cancellation. Okay, so just b squared. So just remove this one. Okay, so that is simplified. Then 25 divided by 5 is 5. Okay, then we have 5a cubed over 8 raised to 9. So you can write, actually, you can also write here as 5 over a raised to n minus 3. So that can also be, okay, so I will write it here. We can also do the same. Okay, so I will show you for number 7, we have 25 a cubed b squared divided by 5 a raised to n b squared. Okay, so we can just divide 25 by 5 is equal to 5, and 5 divided by 5 is 1. So what will be left is 5. Then we have a, let us assume that n is greater than 3. Therefore, we have to write it in the denominator, n minus 3. Then we have b. We can just cancel this out. And therefore, our answer will be 5 over a raised to n minus 3. That is just the same as our formal answer. Okay? So that ends our topic on division of monomial. Okay? Let us take a check up of our module. Then for our first topic, we have to find the algebraic sum of number 1, x raised to n, 2, x raised to m, and 3x raised to n. So we have to follow that the letters should be arranged algebraically, or what I mean is alphabetical. So we have to start with letter M for the power. Okay, so we have to add x. Sorry, I have to. Okay, x raised to n plus 2 x raised to m plus 3 x raised to n. So you will see here that our powers or exponent are n and m, and our base are all x. Okay, so therefore our solution will be, we have to start with 2 x raised to m plus x raised to n plus 3 x raised to n. Okay, now we can only combine the second and the third term because our exponent for the first term is m, and therefore we need to copy 2x raised to m. Then we have x raised to n plus 3 x raised to n. So meaning we have here 1 and we have here 3. Therefore, that will be equal to 4 x raised to n. Therefore, this is now our final answer. For number 2, so we have 12 a squared, then 3 a squared, then negative 14 a squared. Okay, therefore, we have to add them all because their bases are the same and we have a numerical exponent. So, therefore, this is equal to 12 a squared plus 3 a squared, then plus negative 14 a squared. And therefore, we can factor out the coefficient. We have 2 plus 3. Then we can subtract 14 then factor out a squared. So we have 12 plus 3 is equal to 15 minus 14 is equal to 1. Therefore, our answer is equal to a squared. Okay, that is for number 2. For number 3, we have 4x squared. Then we have xy. Then next is negative 2xy. Then 3y squared. And last, y squared. Okay. So therefore, we will start with 4x squared. So we have 4x squared. Then we have no more x squared. So next will be xy. So we have plus xy. Then plus negative 2xy. Okay, so we are done with xy. Then plus 3y squared. Then plus y squared. So actually, we have already arranged alphabetically the letters, and the first letter is arranged descending while y is ascending. So we have 4x squared, therefore this will be equal to 4x squared. Then we have xy minus 2xy, so that is equal to we have minus xy, then plus 4y squared. Okay, so we have xy minus 2xy is equal to negative xy. And again, this is our final answer. For number 4, okay, let's proceed to number 4. Okay, for number 4, we have x raised to n, then negative 3x raised to n, next 5x raised to n. Okay, again, so we have x raised to n plus negative 3x raised to n. Okay, this is negative. Then plus 5x raised to n. Therefore, we have 1, then plus negative 3 or minus 3 plus 5. Then factor out x raised to n, and therefore that is equal to 1 minus 3. Okay, that is 6 minus 3. Therefore, we have 3x raised to n. And that is our final answer. For number 5, okay, for number 5, we have, okay, so we are done with addition. So let's start with subtraction. We have to subtract. Okay, I will copy the problem first, or the question. So subtract for number 5, negative 7m squared, then minus 3m squared. Okay, so therefore we have negative 7m squared. Okay, we have to proceed to addition, and change the sign of the subtrahend. And therefore, we are adding the same negative. Therefore, just get the absolute sum of the absolute value. Then we have negative 10m squared. Okay. So number 6. For number 6, we have 17b minus 16b. Okay. So we have this is equal to negative. Oh, sorry. So we have 17b. Then we have to proceed to addition. Then change the sign of the subtrahend to negative 16b. And therefore, we are adding unlike term. Therefore, we have to get the difference of the absolute value, and that will be equal to 1. And therefore, our answer is B. Okay? Then we have number 7. Okay, for our number 7, okay, for number 7, we have 3a raised to n, 3a raised to n, minus negative 2a raised to n. And we have 3a raised to n. Proceed to addition. Change the sign of the subtrahend. So we have positive 2an. And therefore, we have 3 plus 2 is equal to 5. A raised to n. And that is our answer. For number 8, okay, for number 8, we have 5a raised to n, 5a raised to n, x raised to m, minus 3a raised to n, x raised to m. Okay, so we have 5a raised to n, x raised to m, then proceed to addition, then change the sign of the subtrahend. So we have negative 3a raised to n, x raised to m. Okay, so therefore we have, okay, adding unlike sign, we have 5 minus 3, that will be equal to 2, a raised to n, x raised to m. Okay, so that is number 8. Okay, so we are done with addition and subtraction. So next will be multiplication. Okay, so let me erase first our writings on the whiteboard. Okay, so let's proceed to multiplication. Okay, find the product. Okay. Okay, find the product. First, we have, that is question number 9. We have negative 2 multiplied by 7a, then multiplied by 3b, and multiplied by negative x. Okay, therefore, we have to get first our coefficient. We have negative 2 multiplied by 7 multiplied by 3, then multiplied by -1 for x, and we have a, b, x. And therefore, we have negative, positive, positive, negative. Therefore, we have a positive answer. And that is equal to 7 times 2 is 14, or 7 times 2 is 21, times 2 is 42. So we have 42 A, B, X. Okay, for number 10, so we have number 10, x raised to n, then x squared. Okay, so that is just equal to x raised to n, then let us add 2. So the solution is to add the exponent, and that is already our answer. For number 11, we have ABX multiplied by A squared B X squared multiplied by 2 AB squared X. Okay. So therefore, we have our exponent, our coefficient is only 2, so we have 2. Then we have A, so we have 1 plus 2 plus 1. Okay, so we have 1 plus 2 plus 1. And we have B, so we have 1 plus 1 plus 2. So we have 1 plus 1 plus 2. And for our X, we have 1 here. So 1 plus 2 plus 1. So we have 1 plus 2 plus 1. Okay, therefore we have 2. For A, we have 1 plus 2 plus 1 is equal to 4. B, 1 plus 1 plus 2 is equal to 4 also. And for X, we have 4 also. And therefore, this is our answer. Okay. For number 12, okay. For number 12, we have negative 3x squared y. Then we have 3x y squared. Okay, therefore we have negative 3 multiplied by 3. Then we have x, 2 plus 1, then y, 1 plus 2. Therefore, we have our answer is negative 9 x cubed, then y cubed. Okay, that is our final answer. Then next we have, okay, let's proceed to division actually. And the question is to simplify the following. Simplify the following. Okay, so we have for number 13, we have 64 x raised to 4 divided by negative 8 x squared. Okay, therefore we have We have 64 divided by negative 8. Then we have x raised to 4 minus 2. And therefore, we have negative 64 divided by 8 is 8. So we have 8x squared. And that is our answer. For number 14, in number 14, we have 45x raised to n divided by 9x squared. And therefore, we have 45 divided by 9. Then we have x raised to n minus 2. And therefore, for our final answer, we have 5x raised to n minus 2. Okay, and for number 15, we have 25 c cubed divided by 5c. Therefore, we have 25 divided by 5. Then c raised to 3 minus 1. And therefore, we have 5c squared. Okay. For number 16, we have negative 4. Then x raised to 2n y cubed divided by negative 16 x raised to n y raised to m. And therefore, we have negative 4 divided by negative 16, put it in the parentheses. Then we have x raised to, 2n minus 1. Then y cubed minus m. Okay. So therefore, we have, negative divided by negative positive. Then we have 1/4 x raised to 2n minus 1. Then y 3 minus m. Okay. So, 2n minus n, 2n minus, this should be 2n minus n, and therefore we only have 2n here. So therefore our answer is 1/4 2x 2 x raised to 2n, then y raised to 3 minus m. Okay. So for our next topic, we have to simplify these problems. Okay, simplify these problems is actually involving zero exponent. Okay, so we have number 17, x raised to 0 multiplied by x squared, then x cubed. Okay, therefore, x raised to 0 is equal to 1 multiplied by x squared or plus 3. And therefore, our answer is equal to x raised to 5. For number 18, we have 2ab parentheses raised to 0 all over 2ab raised to 0. Then we have any number raised to 0 is equal to 1. Therefore, 1 over 1. And our answer is 1. For number 19, we have 3x raised to 2n divided by 9x raised to 2n. Therefore, we have 3 over 9. Then we have x raised to 2n. Oh, sorry. 2n minus 2n. And therefore, we have 1/3 x raised to 0. And therefore, that is equal to 1/3 multiplied by 1. And therefore, our answer is 1/3. Okay? For our last number, that is problem number 20. Okay, let me put it here in this space here. So we have number 20. Number 20. So we have 2x squared y cubed c raised to 4. Okay, we have parenthesis 0. Okay, again, any number or any term raised to 0 is equal to 1. Therefore, our final answer is 1. Okay, so that ends our lesson for this video. Thank you.